Hello and welcome to AUTOMAT Live-Coding, the stream where we write AUTOMAT, an application that can play other games. Right now it plays Black Myth Wukong for us and gets some XP. So the way that AUTOMAT works, you can see it in the upper left corner of the screen. It contains a bunch of smaller machines that can be combined together to achieve the desired effect. Usually it relies on sending input events to other windows which are active on the desktop. During the last stream we started playing Black Myth Wukong and we created a macro that was killing this guy, like here, and then it was running towards the guy near the river. And the guy near the river was killing us. So we had this macro which got us, I don't know, 30 something XP, and it took about 2 minutes to complete, maybe less, 1.5 minutes. So it was relatively slow. After the stream I played a little bit more and managed to improve the macro a little bit. So now it takes just 32 seconds for a cycle. And the cycle is fairly deterministic. It doesn't include any variable parts. I left it overnight for 1 day, and it brought the character, I think 20 something level, I think 28 levels. So yeah, it kind of works. And 28 levels is a lot in this game. So the level scaling seems to be very flat. It's probably 29 levels right now because it apparently got a new one recently. Anyway, the level scaling in this game seems very flat. In many games the level scaling follows exponential kind of curve, like Diablo for example. Each subsequent level requires for example 1.5 times XP as the level before. So you cannot really grind on low level kind of guys to get to high level. But in this game, level scaling seems to be, it feels to me like it's quadratic, so that, or maybe even linear, in a sense that each subsequent level requires some fixed extra XP, or maybe some fixed number, maybe level squared, something like that. I'm not sure, I don't care, because as long as the kind of scaling is sub-exponential, we're fine. Leaving the macro for, even if the scaling is quadratic, leaving the macro for 4 times as long would kind of keep leveling us by the same number of levels. Anyway, we are not going to idly sit and watch as AUTOMAT plays Black Myth Wukong, although we may do that. We will be actually coding. I have a separate machine in front of me. This one, which we can use. I did have some free time and I did some experiments with new kind of models of computation in AUTOMAT. Do I still have it here? The levels are increasing very slowly now. 43. Okay, so I have this file called threading model bench. So I mentioned that we'll have to do something with AUTOMAT because we have this big problem with desynchronization. Let me open roadmap. That looks like a good place.
Knight says.
Hi, everyone.
Hi, Nate. Okay. So desynchronization. We had this issue in Mario, but even the improved macro in Black Myth Wukong also has those issues. When I left this overnight, the next day the character was actually stuck in some random place. So yeah, we still have some things to improve. So the ideas for desynchronization were as follows. Number one was to record windows, like the video from a window. We could capture screenshots, for example, when the key is pressed, the key or mouse is being pressed. Or we could capture the screen at a fixed capture rate. And then maybe we could use that to kind of slow down or accelerate the macro playback. However, this is going to be difficult. This is more like an open research project than like a reasonable solution to this problem. I also don't see any like rock-solid solution here. Okay, the next one was to monitor app memory for events, and that could be for example, like GL Sync or Vulkan equivalent. This is something that could let us use like a different unit for measuring, time. Instead of measuring time in seconds, we would measure the time in frames or some ticks that the game manages. And we could extract them from game's memory. The problem with this approach is, okay, so the problem with this one the problem with recording windows is that it's very rare that stretching the macro playback will actually fix it. When the desynchronization happens, we are in this chaotic domain where the game can go in arbitrary direction. This is uncharted territory, and slowing and accelerating playback is not going to recover from this. So the problem with monitoring events, they are very application specific. We would have to introduce some kind of hooking library, like hooking objects into AUTOMAT. I mean objects which could hook into target game. But then we would also need some objects to analyze the game so that you can find a good place to hook. So they are very application specific and need a lot of actually all of the solutions will need a lot of extra support objects, but this is very application specific, could be complex. We will probably go in this direction eventually, because hooking memory and like interfacing with other applications is definitely what we want to do. Oh yeah, this was the same thing. Okay, the next idea was to introduce high priority events. This is the easiest approach. So the idea there is we keep AUTOMAT single-threaded. But when we are rendering a frame, we are constantly checking if there is any new task in the high priority queue. And if there is a task in high priority queue, we could either pause rendering while task executes, or cancel current frame. Does this pose any problems? Yeah, there is a small risk of locking AUTOMAT. But I wouldn't worry about that too much. This approach also excludes concurrent execution. And concurrent execution is something that I think is very valuable and something that we could actually pursue. Okay, this is interesting, those procedural macros. So the idea with those procedural macros is that instead of having a single large macro that can do your whole logic end to end, we will have many smaller macros. For example, right now we're kind of running to this dude, we're attacking him, then we're coming back. So we could have one macro that runs to the dude, attacks him, and another which runs back and forward until we get this, for example, E kind of key visible, like the option to open the shrine menu. And that other macro could actually vary its own behavior. So it would, for example, keep pressing W until some pattern on screen appears. Yeah, and I think many macros in AUTOMAT are actually going to be built like that. So it's not really... we will do this anyway. The problem with this approach, it requires fairly difficult setup from the user. It's like programming a bot, essentially. You have to program every kind of procedure, and that procedure will kind of... you have to start thinking about macro like a programmer, breaking it down into sub-problems and debugging sub-problems individually. Yeah, many problems will require something like that. Similar to this memory monitoring. I think if we combine procedural macros with memory monitoring, at this point we can really play any game. But this will involve a lot of extra objects. For procedural macros, we will need window recording, we will need a lot of kind of common kind of utility objects like pattern recognition, wait until something happens, and then do something else. Our key presser objects, which right now is just a single object which gets like on or off signal, would have to be kind of split, or maybe not, into like press and release objects, similarly to how we handle mouse. Anyway, so we have those 4 solutions, but there is a 5th one. The 5th one will actually not involve any new objects and may make AUTOMAT more like... it will significantly reduce desync, I think. So the other idea is to have concurrent execution of objects. So even while we are rendering a frame, which can lock AUTOMAT for like 100, or not 100, like 10 milliseconds, for example. So the idea is that when we render stuff, instead of just taking over AUTOMAT thread and blocking everything until we render the frame, we would just lock a single object that we are interested in at the moment, maybe create a copy of its internal data, and then release the lock as quickly as possible. And then we will render separately from AUTOMAT logic. And AUTOMAT logic itself, it could also be kind of multi-threaded. So when an object executes, it will be locked. We will apply some transformation to the object, and then we will unlock the given object. And depending on the object, we may need different types of locking. Sometimes this will be a mutex, sometimes this could be an atomic, sometimes this could be some kind of copy on write structure, or maybe if there are like no side effects, an object that doesn't really store anything. For instance, like a date function. So yeah, so sometimes we wouldn't even need any locking at all. Hey Faritabri. Yeah. So specifically, I'm not playing Black Myth Wukong. AUTOMAT is. So the window in the upper left corner is a macro, which is executing this short loop. So every 30 seconds it's killing one dude, coming back, respawning all enemies. And yeah, it's doing that over and over. Hi Azotek. Okay, so let's keep it playing. Okay. Let me pause this because the TTS stopped working. So I think what happened now is yeah.
Just an ordinary monkey after all.
Oh, maybe not. Yeah, my PC has those issues where sometimes it will, like the network card will just crash, but that's not an issue. I will have to just reboot it. Okay. Let's go back to Steam. Anyway, I was talking about desync. It will start in a moment. So, the extra solution to the desync problem is that put some synchronization in every AUTOMAT object. And this may seem crazy because it means that execution of small programs is going to be super slow. Imagine a loop which just increments a number. Every time we increment this number, we will have to lock the increment object because the increment object needs to check its arguments. Then we will have to log the integer and atomically increment it. And even though those operations are simple, relatively fast, each of them forces the CPU to do this expensive long-range kind of memory access. The CPU has to look into the CPU level cache every time we do a synchronization like that. And it's extremely slow. It will, high performance loops will be 1,000 times slower if we do sync every time. Maybe in AUTOMAT it's not going to be as noticeable because AUTOMAT is kind of slow anyway. But I'm thinking that maybe this slowness is not going to be such a big problem in AUTOMAT, because most actions that we do in AUTOMAT, they are rather heavyweight, like sending an event to an active application. This requires a lot of synchronization anyway. There is just locking a mutex is not a big deal. It's almost nothing compared to the cost of, extending an operating system event. Okay, and now I can press F1. I will actually, okay, should be fine. Yeah, we are back to grinding. So actions in AUTOMAT, I think, will be fairly expensive, so that the cost of locking is going to be negligible. And about high performance actions, when you need to do something which requires high performance computation, I'm thinking that those things will be done better in assembler. So we will have this object to combine assembly instructions together. And I think if you have some math, for example, to do this in assembler, absolutely. Yeah. So AUTOMAT will have this high-level thread-safe mechanism for arranging object execution, and each object itself could be incredibly fast. The only thing we really have to take care of is this kind of locking. Yeah, and locking is going to be slow. So I mentioned I was playing with this idea, and I have a prototype. The prototype is not really ready or complete, but So what I've tested. So there are a couple of ways of arranging object execution. The easiest one is to have an object send events to other objects. Those events are unidirectional, we don't expect them to ever come back. So this is kind of the way that AUTOMAT works right now. We have objects that kind of send events to some output kind of connections. This is fairly easy to parallelize. So first of all, out of all of the objects that we activate, we could highlight one of them, and that one object could be the main line. So when we have an activation, when we have a single thread, an object executes. And for example, this object wants to schedule to wake 3 other objects. One of them we can execute on the same thread without having any queues, any stacks, any, oops. Stop. Don't need the music right now. So one of the objects is going to be, one of the threads of execution is going to form a main line. So we will just have a loop, a single thread with a loop that executes an object, it gets the next object to execute, it executes the next object forever. So this is the main line execution. It's going to be relatively fast. If we have just a single main line, we don't need to lock anything in AUTOMAT. Only when we get some extra threads, this is when the kind of locking becomes necessary. And we could actually have a global variable in AUTOMAT. Or maybe not a global variable, but we could have maybe an argument that we will pass. Oh yeah, that actually could be a very simple global variable that we could just check, and when it's true, then it means we can skip locking. So the execution could be very fast. Still. Then next thing is sidelines. When the execution actually forks, when we have an object that executes, it wants to wake several objects right next to it, for example, and the next one, then only one object can be executed immediately by the same thread. All of the extra objects, they have to either be added to some kind of queue or a stack, or those extra objects could be, and if we have extra queue or extra stack, and then we could also have extra threads, and those extra threads could execute those background kind of tasks for us. And if we introduce extra threads, then we will have to start locking. The interesting thing is that any of those objects which can be scheduled like on the side of the kind of root object, they themselves, they can execute using this mainline kind of model. So if there is a long chain of objects, we don't need to start any extra threads. They can all execute on the same thread. Or we don't need to, we are not going to start any extra threads. We will just have threads waiting for work. Yeah, but yeah, this is going to be the plan. So here I have a small benchmark where I checked first. I tried the atomic approach for locking fields in objects. So in this kind of small model, every object has a next pointer. And for example, the integer object, it holds its value in an atomic variable. When we want to increment something, first we load this connection, which is this atomic weak pointer. So we can load this without any locking, and we are checking if we have a pointer that points anywhere. Once we get this pointer, we just increment it. And that incrementation is actually atomic, because integer holds I in an atomic field. And when we exit from this, we return the next object to execute, which is usually like the same. So this incrementer usually just returns itself. But again, it has to load kind of the next pointer using the atomic operation. So I did a benchmark of this approach and the other approach which relies on mutexes. So the mutex approach blah blah blah. We call this. In the mutex approach, we have very simple objects, kind of empty object. But each object can actually introduce its own mutex. So when we want to read the value, first we have to log the mutex, then we read the value. In the incrementer, actually we could use a mixed approach, I think. In the incrementer, we don't need atomics here anymore, we just need one shared mutex. I didn't even use this getNumber function. Anyway, it does a very similar job, but using mutexes. The performance of mutex approach and atomic approach was almost identical. I have some numbers here. So there we go. So mutex approach was generally just faster. It was faster when executed with a single thread. It was faster when executed at 16 threads. And as I mentioned, the single-threaded approach where you have no locking was just incredibly fast. It was more than 10 times faster. It was like 12 times faster than the, second best place. Yeah, so locking is expensive. If we can avoid it, we should. But I've introduced this special kind of mode into this benchmark called slow increment. The point of slow increment is it just sleeps for some time. The point of this is to simulate expensive tasks. Maybe 1 millisecond is kind of pessimistic because most tasks are going to be way, way faster than 1 millisecond. But when I enabled this slow increment mode and benchmarked everything, at single thread, all of the solutions were identical. And at 16 threads, Atomic and Mutex were identical, but the Q approach, the single-threaded approach, was just, 16 times slower. Yeah. So single-threaded has strengths, but it also has weaknesses. If we can figure out how to introduce this extra variable that will allow us to avoid locking, if we can do that, then I think we could have the best of both worlds. Yeah. I think checking a variable like a boolean, or it would be best if we could force this to be a register. It's going to be definitely faster than locking mutexes or atomics. And there is this funny thing, because when I was looking at online materials about concurrency, there is this apparent obsession about lock-free data structures and lock-free, algorithms. And the crazy thing is, lock-free only is relevant when your system is already congested. When you have way too much work. This is when lock-free is, let's say, interesting. If you can just balance your system to just not start too many threads, or just have a fixed number of threads for doing the heavyweight processing, there is really no need to lock free anything. If you can balance your work properly, mutexes are better than atomics. So, yeah, it's this whole trend is very surprising to me. Digression. Okay. So, I said I have done this benchmark, and I got some numbers. But this is just the simplest case, because this continuation passing model, it could work, but not all of the objects can be executed like that. For instance, if you imagine a function, a reusable function, if in AUTOMAT you create a reusable function, then if you want to reuse it, you have to duplicate it in multiple places. So you cannot really have a fixed number of objects to work, perform a function for many different locations in your machine. You cannot concentrate, you cannot create a single complex, polished, piece of machinery that can be reused in multiple places without being copied. There is a completely different computation model called functional, functional programming or lambda calculus or just sub-procedures. The idea there is that we introduce a stack, or we don't really have to introduce a stack, but we introduce some kind of mechanism so that concurrent execution, if two different places in the code, if they want to execute the same sub-procedure at the same time, we have to find a way to kind of avoid this conflict somehow. There are two ways, two broad kind of solutions to this problem. One, and there is like a memory space trade-off there. Approach one is we could pause the execution of the second object, wait until the first object finishes. When it finishes, the other object can execute this procedure, right? So this is the locking approach. Sorry, the time-based kind of approach. The other approach is based on space. You could allocate extra space. So if there are two places which want to call the same sub-procedure, we could duplicate the sub-procedure and the other place could call its own copy, right? And this is how stacks work in traditional programming languages like C or everything based on algol. Yeah, so there are only those two kind of approaches. We have to either trade off space or time. And I think in AUTOMAT it should be possible to call a sub-procedure, but to dynamically change how you call it, to switch between this locking and to switch between time and memory consumption. Like, you can choose between speed or memory efficiency. It's a nice kind of idea. But to implement this, we will need some extra machinery. So, let's say we have a function object that can be called from multiple places in AUTOMAT. I think this object could have a callback pointer. So when you want to call a procedure, you can see if this callback pointer is connected to any other object. If it is connected, then you wait, then you block until it is disconnected. Or if it is connected to another, or if you have this flag which specifies that you should duplicate, the target object, you can create a copy of AUTOMAT objects and call this copy. AUTOMAT objects are very cheap and they have this clone method, so cloning a bunch of AUTOMAT objects is fairly cheap. We can do that. Okay. So there is this callback pointer that we have to manage carefully now. So my kind of experiment finished on implementing this callback mechanism. If we can implement this callback mechanism, it's going to be awesome, because we will be able to have function calling in AUTOMAT, and this function calling will be kind of switchable. You will be able to switch between a nice, well-behaved, kind of, quote, single-threaded execution and between just disposable copies of the object. If you have a stateful object, then you kind of have to lock it. But if the object is stateless, if it's a function, then you can create a separate copy of this object and execute only this disposable copy. Yeah. Actually, this is a nice... And this is actually a nice property that we could use to automatically decide whether to use duplication or locking. Anyway, so we have those two models, right? The first one, let's call this continuation passing. Or like, not continuation, like direct threading. Okay, maybe direct threading is the best word. Because direct threading is a well-established term. Everybody knows what a direct... Okay, maybe not everybody knows what direct threading is, but... if you check up Wikipedia for direct threading, this is kind of what we would do. And the other approach, which is based on calling procedures, potentially synchronized procedures. Okay, so two approaches: direct threading and sub-procedures. There is also a third approach. The third approach is based on multi-directional computation. So there are some objects in AUTOMAT which describe a relationship between data, and those objects can often be executed in multiple directions and immediately reactive. Oh, maybe reactive is a proper kind of term for that. So let's switch to nano. So here we have those different computation models. So we have this direct, execution, so sub-procedures calls they return, and they may have state. Okay, the next one is, I called multi-directional, but better name is reactive. In the reactive approach, objects observe one another. When an object is updated, an update propagates to its neighbors. Okay, there is also this rule-based, but I think rule-based is actually a subtype of reactive. Or there are different ways to apply rules. They could be applied periodically, on change, or at a very specific kind of rewrite point. So they are something different. So reactive execution. So we could, I guess, implement reactive just on top of direct execution, I guess. So when an object changes, so it notifies all observers, and it should call them somehow. And I think if we piggyback on this direct execution model, then we will execute only one of those updates directly, and all of the others will be added to some queue or sent to background threads. When I look at those different kind of ways to execute stuff, I'm starting to wonder, specifically because we have this new way of calling functions, where we will change the callback kind of pointer of an object. I wonder whether we need machines as an object at all. I'm trying to add some transparency here. Maybe color key. Yeah, this is certainly some Okay, I was thinking about this reactive. So let's say an object changes, it has a bunch of observers. We can pick one of those observers, execute it immediately, and all of the others could be added to execution queue. So do we need a machine? So the way I see this is when we have a call, when we call another object. Maybe I can find a better team. I think we could have just a lightweight object which will hold, like, not like an object which will hold a couple other objects, so that when there is a procedure call and we have to kind of use other objects, we will pass this information like something like a stack frame. Yeah, so when we will be calling other objects, they will get access to this extra stack frame so that they don't, for example, mutate themselves accidentally. They will kind of, if they have to mutate something, they will clone themselves and add themselves to the extra stack frame. So a big problem in figuring how to flatten the call hierarchy in AUTOMAT is to try to find a way to avoid using the C stack, because it's very intuitive. It just the C stack just begs to be used for that. So that we could have a single loop, which when we call a sub-procedure, we will call it in a sub-procedure. But I want to avoid that. I don't think this is the right way. I think the right way is going to be to have just a single processing loop, which will call the object. The object will do its work and then return back, waking up whoever is waiting, possibly. Okay, I think I could remove some things from this benchmark. The atomic, for instance. I've tested atomic, I know how it behaves. I could get rid of the Q, and I could actually just remove this wrapper here. So this is a small kind of example. I think it's easier to prototype here than with, AUTOMAT, because AUTOMAT has a bunch of objects. We could incrementally kind of improve them or push them in the right direction, but we should know what is the correct direction. So here I was trying to figure out how this model could work. The idea is that I have this squared object. It has a pointer to some number and a callback pointer. And the idea is that I want to expose a function that looks like that. Simple function that just returns an integer, right? The point here is that I want this function this should execute the processing loop and execute it until the end. I mean, until so we have a mutex here that I am locking. I actually shouldn't lock it, definitely not for so long. Actually, this whole thing is... it's not the best, so I will just skip this. I will remove all of that. Oh yeah. So I've implemented this extra object called task, which holds two things. It holds a pointer to an object that's supposed to be executed. This is a weak pointer because I think if an object is deleted for some reason, its execution kind of should be cancelled, and this allows us to kind of cancel the execution. So every connection between objects is a potential cancellation point, and it's safe. So this is the loop which executes tasks. We give it an initial task. It converts the weak pointer to the shared pointer. It finds the method within the object, the one from the pointer, and it calls it with the shared pointer that it obtained. Fun thing is that if an object is being deleted, the object will kind of keep itself alive until it returns from this method, because it gets a shared pointer, and this shared pointer is going to be destroyed when we return from this method. So we have this function run, right, which runs the object. But I wonder. So this function should return a task, I think. Yep. Okay, so by default, when we run an object, we do not return any kind of successor. So this one is called, should be called let's call this run mainline. And this integer, I think I will just change this to atomic. We will not have the getNumber function. And this is going to be a regular. Oops. Okay, so here's what I think we could do. I want to split. Okay, I think. So I think this squarer object could work like that when it's executed. It looks at the number here. It takes its value and it writes it into the result field. Or maybe instead of result field, it should have a result pointer. And the callback. No, something's not right. It shouldn't store the result externally, because if I want to chain multiple squarers together, that chain would have like a bunch of connections. I think it should be like that. So let's think about the different states that the object could be in. First is ready to be called. Then it's possible that somebody called us. Somebody called squarer, so they've set the callback to some value, but the squarer, to compute its value, it has to call another object. So, waiting for sub. When we are in this waiting state, okay, I'm using those events. Okay, let's do this properly. So each of the properties is going to have those backticks. Events are going to be wrapped in sharp braces, and states are going to be in parentheses. Oops. Now I think we need this extra state for returning. Okay, so this is where the computation happens.
My shield won't hold! With me, bastard! Back!
So here we compute our value, we put this in a specific field, and we schedule
My shield won't hold! With me, bastard!
that kind of state logic is fairly basic. I think it could be simplified a little.
My shield won't hold! With me!
Okay, this locking, I don't think it's even necessary because we have this callback. The callback is kind of like locking.
AUTOMAT! He will kill you!
So I think this is also where we should do that. those states. I am kind of listing them explicitly here, but I think they will be completely implicit, because those states, they are kind of irrelevant as long as we make sure that the messages are passed properly. For example, when we get a call, we transition to one of those two states and we send either a message here or a message here. Maybe this transitioning, let's call this done. This callback is a very nice primitive. I wonder if we can wait on an atomic value in C++. Nice. We also have notify 1. Super nice. And there was also condition variables. Interesting. So condition variable weight. Is there a documentation for this function? Okay, so we can also use condition variables, alternative to atomics. Yeah, and we can use even this predicate version of condition variable. Let's check those things. Okay, shared mutex is fairly small. Eight bytes. Really? So nice. And regular mutex. 80. Okay, condition variable is rather large. What's that? Why does it say? Okay, now it's better. What's in this class? I'm checking the size because in an object we have to pick one of them. Either we will use atomic, which will consume extra, no, actually nothing extra. It uses the same amount of memory as regular weak pointer. It's just we fetch it using a different CPU instruction. Or we could have something like that, callback to, which is going to be a regular weak pointer, but it's going to be protected by this mutex. Or maybe, yeah, we just have to keep the mutex there. So condition variable, I guess, could be ephemeral. So just 8 bytes, I guess. So the nice thing about condition variables as opposed to atomics is that here we can use durations. So we could have a code in AUTOMAT that tries to call something, but if the target object is not available for too long, it could like switch to a throw an error or switch to a backup. So first we have this call function. We are locking our mutex. This could be unique lock. And by the way, I was wondering what's the difference between mutex and shared mutex? I'll be right back. Okay, so to execute everything on one thread, I think what we should ensure is that when we get a call, we should as a main line return the return message or the call message for the sub-object. And just the same. When we get a return, yeah, we should propagate the return again using the main line code. Yeah, this funny construction is going to allow us to have like multiple stacks of function calls that can call each other on multiple threads even, and they should not have any issues. If there is an issue, like one of them will just block and wait for the others. Okay, so that first point is done. Is it possible to avoid locking? Yes, it is. We only have to lock it initially when we change callback from null pointer to some value, and then the square error is kind of readable globally all the time by everyone. And given that we already have a shared mutex here, I think we can use that instead of atomic for the callback. So we will have condition variables. I just wonder if we have to use the same condition variable. Check this out, there was this issue. I was waiting for this to happen. Okay, let me stop the macro. And open Twitch. Can I rewind? Can I rewind? Be quiet. Nope. Maybe on YouTube. the same. Okay. So now we can follow what happened there. So we have been running towards this guy. Attack. We have to move automat. I just wonder if we have to... Okay, so we just ran a little bit too far forward. So I could fix the macro by maybe increasing the time that we go back a little bit. See again. We are going back. Turn. Okay. We shouldn't go that far. I will close this macro. Stream. We seem to have an issue in AUTOMAT, but anyway. W, this one. Or actually not. Yeah, this one. So we press it for roughly half a second. I could make it shorter. Like that. And I think that should reduce the number of issues. Nice. Seems to still work. Speaking of grinding, it's going fairly well. I think when we hit level 46, I will see how strong the character really is. So when we are calling this thread. Yeah, I wonder if I have to have this condition variable there, or maybe I can have multiple condition variables. And notifies the condition variable. Okay, the question seems, that question from Stack Overflow seems it's asking the like opposite way, the question. It assumes that you're using multiple conditional variables. Okay, when I call notify all or notify one, who is notified? I still have no clue. Be right back again. Another bug I see. Let's see how this one looked like. It's not nice that I am streaming this because it's not. I can see and investigate the errors now. Okay, something weird happened. It looks like we didn't slept. Interesting bug. Where is our timeline here? So here is the object which presses the E key to sleep. I think we could move it maybe 100 milliseconds forward. Cool. Okay, so when we call, we should take a look. Then we will Wait. Okay, it has to be a regular mutex. It would be nice if I could take a look and see. If we have a shared, if this weak pointer is pointing at anything or not. Okay, so I have to lock. Moment. So now that CV is locked, this function call also needs a caller, which could be a weak pointer. So this is the first part, the blocking part. So this and this. Another issue I see. Wait, I'm sorry. Okay, so this is looking nice. We are casting the spell. There is heavy attack. And we're coming back. Oh, here we got hit. Huh. Interesting. I could start charging the attack a little bit earlier. That's one option. Let's try charging the attack a second earlier. This worked pretty nicely. The big question is, yeah, we don't seem to be able to get back. Let's try again. Here we have some A presses. Maybe I can remove them. I could combine them into a single key press and shorten them. Maybe I will keep the second one.
Just an ordinary monkey after all.
Now we have just one A press. And I could also shorten the S. I see. Let's do that. maybe half a second shorter. Seems to work. Since it's working, apparently. We will see how long. We can go back to this. So let's first implement the part where we have this. Have been called. We waited until there was callback was null pointer. We've changed the callback to whatever was in color. Then we have read the pointer to the object, to the integer. We square it, and then now we should switch to the returning state. So now we have to call send return to callback. It's amazing what C++ allows me to do. So this is a pointer to a member of a class. So I'm taking a pointer to the return function and returning it here, so that the execution loop will execute it. Next. Okay. Okay, so we have implemented this part. I think I will put a return function within object. Maybe instead of those pointers, we will have that. Another interesting error condition I see. Let's see what happens now. Okay, there was another issue with resting. Maybe I will just push it another 100 milliseconds forward. Seems like I made a mistake when I edited it last time. Oh well. So actually, speaking about the desync issues, I think another way of solving those issues is by tweaking this macro. It is not easy to do because it requires a lot of fine adjustments. For example, if we want to shorten a section, do we also want to move all of the subsequent sections closer or not? And when we return a task, we should return it maybe as a unique pointer. I think this return from should actually have a regular shared pointer. Okay, and our return task should contain the callback and self. So we've done the squaring, transition to returning. Yeah, we are in the returning state. And we are sending the return event to the callback. Cool. Now the other part. Okay, so the number, if it's not an integer, it should be elsewhere. Right. I guess now we have to return, to handle the return code, because the call seems to be finished. We should get a new level very soon. So if we didn't have any number, Yeah, this is like the error condition that is unlikely to happen in our test case, but let's implement this properly. Return function. Okay. Now we can proceed the same way as here. We are writing the results. We should also call it done there. Something like that. And now we can return. Sorry, no. I think I can write the result without the lock, because the thread which owns the callback pointer, it's free to modify the result. Or maybe not. Yeah, I think it's not. Because if we are concurrently rendering this object, then we don't want to render like a malformed value here. Okay. we are clearing callback and notifying one of the waiting threads. Nice, level 46. Okay. And this way the called function, the called object is being also kind of released. It's not super fast. 6 million iterations per second. The test is just incrementing a bunch of numbers. So it's not really checking the calling logic. Oh, and I didn't implement the call function yet. I also have to think how that will work. As you can see, the difference between multi-threaded and single-threaded is not really that high. At 16 threads, it's barely 4 times faster. And yeah, the overhead from locking is just terrible. For comparison, single-threaded implementation would be more than 100 times faster if it didn't lock anything. Yeah, but this is how it has to be. I will create a new test suite. Or something called just call test. Oh, we have a bug in the macro. Let's see. Actually, no, it works. What? Okay, for a minute I thought something broke there. So the plan is so there will be one integer in the center and so there will be 16 threads, so Now, okay. Now, this is a very weird test, but it verifies that we can safely concurrently call stuff. Because each squarer and the integer is referenced by two other objects, we can slow down the execution. And if we do that, only one of them will be able to execute. So that should verify whether the sequencing of the objects of the execution is okay. So the two root squarers will execute kind of simultaneously, but two of them, for each of the, maybe those four squarers are actually two groups of two squarers, and each group is kind of mutually exclusive. Only one of them can execute. And really, so this is the correctness test. This verifies that what we do is kind of fine. Okay, I will make a break and after break we will test out the leveled up character. And implement the call test. Okay, so see you in an hour.
Hold the line! Hold the line!
Hello. Let me put this away and let's see what level do we have actually. $47, nice. How did we level up? I guess here. We could fully level up this skill. Crazy. This could be powerful. And we need more levels here, so definitely. Let's go for this. Okay, we have 3 levels there. Now let's level up the basics. Okay. All of the health levels, please. Nice. So we have uber powerful immobilize spell. We have a new stance. How about equipment?
Our king has truly prospered. Someone takes care of after.
That was a good attempt. It was that attack, I see.
You don't want to run into that big head.
There we go. Okay, there was another boss in this area. Sure.
More toil, I'll put you.
He was there.
Buddha's mercy still be on you. Hold the line! Patrol.
I wonder, how do I recover mana?
You only look like him.
Burning damage is strong. But we defeated the first boss. That's some success. I can try the next one. There is like a white wolf if we run past the big guy.
Report that Lordlings.
It wasn't bad. Wasn't bad. That was close. Cool.
You surprised me. Now that it's dead, you might as well take a good look around. A great pill the Black Myth Wukong had gifted the wolf. Finding it would be a deserving reward for that fight.
Fake buildings, yeah. Any rewards here? some materials. Yeah, there is something. And back there, some resources. So there is this road down, but there is also a sideways path. Or maybe not. Not really an open world game, at least not yet. Oh, that's a chest. I guess we have to continue. The only path forward. So I guess now we die because of poison. Weird. That place looks familiar, like I was already passing through this. That was good XP. Okay, I see this tree is not meant to be walked on. No idea what was that or where it came from. I guess if I rest it should respawn. This could be like a better place for farming, because killing one of those guys would be like killing 5 or 6 of the others. Where did he came from? Okay, maybe from here. He became invisible.
Have you seen those nameless souls adrift on your path? Their wheels float aloft, never to fade. Shame, your god serves little purpose, and mine answers solely to me. I know a way to guide the souls, mend their paths, and set them free. It will aid you. Now, this is better. This god, though humble, may save the lost, banish their obsessions, and guide them.
Nice.
For one is destined as you, there can be no turning back. We are like tumble, drifting through life, with a destiny beyond.
And this is probably the path back. Okay. There was one more guy who fell literally through the floor. I don't know where he is. Was it intended or was that a bug? Looks like a nice place, like a boss arena. Okay. It's like a mini boss, I guess. There's nothing here. But there is another path. Is this it? Should we just jump down? I'm using middle mouse button to scan the area for more enemies. Yes, that works. say I am a little bit lost. Let's find some orientation point. This looks like a boss arena.
This humble one's name is Guangmo. Should my demise come by your hands, please pass this message to my master. Searching for deity, mortals do aspire. Craving immortality, Yao Guais surely will conspire! Boys, keep him at in the very end, all dim alike.
Mana. Mana is very useful. If I had more mana, I could lock him down. Okay, let's resume the grind. 3 spirits, let's try this one. Looks interesting. We have so much will, we can upgrade everything. I have no idea how to use that. Let's resume the grind. And in the meantime we can do some coding. All right. We were going to create a test. So let's start with the integer. We have a vector of squares. Each of them will be held by a shared pointer. This looks good, actually. Actually not. I think we have to increase I by 1. And do it like that. Or I will do this differently. We'll have a flat vector of shared pointers. that could have been fine. We just need to do that. Something doesn't seem right. Anyway, I think now we should be able to... We didn't implement the call yet, but we created this structure. We will call this get number function. Now here we have to engage this whole system. So I think we should first create call task. But the caller, maybe caller could be empty. No, it cannot be empty. Okay, this object is just not going to do anything when we run it. But we can call this task. In fact, we can construct it straight here. And so there is a promise in this API that when we call a call function, we will always finish with return. So return task is going to be called. And when return task is called, we should call it on the object. Anyway, this is the place where we should probably copy out the value. And it blocked. Let's add some logging. First of all, I think all of those big functions like return should log stuff. We have call, we have return, we can also have it done. Okay, so the first object was called and it blocked. Maybe that should be implemented differently. Oh, actually not. When I get this log, Nice. And we got the correct result. So the first object got call, which caused a call in the next object. Next. That object, this was a squarer that fetched the value 2 from the integer. And it returned, but this is a different object that returns here. Oh yeah, this was called, this is calling return in the parent object. Yeah. And we are calling done on this one, cool. Here, done, return, done. And this place is actually where dummy object return is being called. I think we could even implement a handler here. I guess now our function, of course it should be marked as override. was this test? This. We don't need done anymore. Because dummy object will now call the done. Yeah, still being called. We'll even change our run mainline function to print the objects, not objects, but pretty nice. So this is our function calling kind of working. Okay, this notification, we are still not doing that. So in the done function we should do... Okay, actually we are doing that. We have notification here. Level 49. Okay, let's go back to our test, and now we will do something harder. I will add a sleep in the computation here. think we should lock gently after. And again. We only need this lock to query the pointer. The integer we are loading atomically, and here we will create another lock. We are pretending that we are doing expensive update. A lot of locking and unlocking for a simple kind of squaring operation, but we will refactor all of that. All of this boilerplate is going to be in some external kind of function. Okay, so we've slowed it down. We can flip the flag. Now the test will also be super fast because it doesn't sleep for long. But it's fast to us. Actually, it's taking multiple milliseconds. So in computer time, it's eternity. I will introduce a different collection here. Called leaf squares. How many of them there are? There should be 16, I hope. Excuse me, what? What? I think the logic changed a little bit. Anyway. Oh, and I see why did we got 0, because when we square this value, it doesn't fit in an integer, it overflows. Okay, that makes sense. Anyway, so the point now is that we'll create a latch. Which will wait for this many countdowns. And we will start a bunch of threads. Anyway, so we are starting a bunch of threads. So we will sleep, we will count down, and then we will wait for all of the threads to finish. And that's it. That should cause an avalanche of execution. And the thing is, I would like to verify that those extra holes that they actually block. So I will print some stuff. Yeah, I want to see some waiting lines in the log. That's my hope. Okay, there were some. Nice. even increase that. One second. Windows Terminal isn't great for debugging. It took 8 seconds to execute. Let's see. I will reuse the nesting level so that it's easier to think about. Now we will have just 8 threads. Or maybe even more. So we have 4 squares and probably 6 total squares. Okay, I think we should also add a weight if it's an integer. first we got all of those calls executed immediately. This is very weird. First we are doing a bunch of calls. 8 of them. 8 of them? Yeah, because in every object we can call it twice. Like this one is twice. And there should be one more which is called twice. This one. First we call them. And then we return. 2 of the objects should return. And we get this message about waiting. We get it. Here. We generally lock this thing for a very brief moment. Here. We have 8 calls, 2 of which are waiting. And then 4 returns, okay. So the std out buffering is terrible, I guess. How is it possible that we kept executing after printing done? Doesn't make the slightest sense. Oh yeah, it's because we called it again. So this works nicely. I guess we could think about API improvements now. API specifically for objects. Writing objects should be simple, instead of having a huge object like this one. All of that. That should essentially boil down to maybe even different. Something like something like that. And maybe not this specific function because it already exists. Looks to me like this should really be implemented as a coroutine, because an object, when it calls another object, this is a potential interruption point. Execution could stop here. And we need to be able to restart the execution from this point. Maybe in this simple case, where we have just a square, like a single argument, single result. This could be refactored to a single function that takes like I, and like the boilerplate code could fetch the values from other objects. But to make it possible to build more complex objects, I think we will have to structure this differently. It will be something like main body, like the logic of the object. And the thing is, whenever we want to restart this function, we would have to jump somewhere in between, like in the middle of the code. We could try to do that with a switch. And in this construct, we won't fall through. We want the code to continue from 0 to 1 to 2 and so on. So we have some initial logic, and when we are doing the call, we'll do the call and return, possibly return. And this is the return part. Okay, this could be repeated. We could have many sections like that. And when we are finished, so the reason I think callback and the next could be combined is that if you imagine an object which does not have a next pointer, then running this object could be like calling it. We could also try something like that. I don't remember what was the syntax for coroutines. But in C++ it's actually possible to do some logic. Call another object which may yield the execution. By yield I mean pause this and return to another stack, kind of. Yeah, coroutine is essentially like a separate execution stack.
Evilite says.
Hello? Wow. How long are you streaming so far?
Hey, since 7 hours, I think. But I left it overnight one day to grind some levels. So from around 13 to 41, yeah, it ran overnight. But it still has issues with desynchronization, or maybe the game has variable FPS, because sometimes it gets stuck.
Are you writing coroutines for AUTOMAT?
I am considering that. So I'm trying to figure out how objects could call each other. With one important kind of property that I don't want to use the C stack, the default stack that the C or C++ provides. Kind of the objects need to kind of establish protocol between themselves so that they can call each other, maybe wait, because in a concurrent situation, like for instance, imagine like all objects running concurrently, like on separate threads. One object could be busy, like doing work for like one part of AUTOMAT, and all of the other objects which are concurrently trying to call it should block and wait and pause their execution until it finishes. Or maybe instead of blocking, they could duplicate their, the target object, similar to how Algol and C and C++ and normal programming languages do. Java, I don't know if you know Java, but Java has this ability to put synchronized on a function. And that actually makes it, yeah, this is kind of what I'm trying to create. I'm trying to create a mechanism to call objects, which will by default block, but will be dynamically toggleable to like a stack-based execution, where each call creates an additional kind of stack frame. And coroutines are just a convenient way to write code. They are maybe even too convenient because they don't capture all of the paths that could be taken.
Well, synchronized is just wrapper around object. .notify object wit.
Yeah, but there is something like, there is a very subtle thing there, because if you have a function, I don't know, print, this print function can have some internal state, like a buffer. Normally in C, when you call this function, it will just allocate this buffer on the stack. In AUTOMAT, this is structured somewhat differently, because the buffer is part of the object. And the print function uses the object's buffer. This actually, so this means that we have to synchronize access to the object, but alternatively, we could clone the object. And call print concurrently using the cloned object.
Clone when?
Before this function is called. Or when this function wants to write some data. But the caller, like, okay, so I'm writing this as a code, but I'm thinking about AUTOMAT objects. So imagine like a printer object and another object which calls it. That printer object holds a buffer. And if it's being called by multiple objects and printing is slow, then only one of the objects, only one caller can be active at a time, unless the callers agree to clone their target. And then we could get a behavior similar to function calls.
So you want freeze state when performing concurrent work?
Not really state, but freeze other threads, because I'm trying to also coordinate work of multiple threads. So this file, the stuff that I'm writing basically the whole day today, is actually not part of AUTOMAT. It's just an experiment, like a prototype for a different execution model, where instead of single execution queue, we will have a bunch of objects, and this bunch of objects will pass messages to each other. It's kind of like there will be no threads in AUTOMAT. AUTOMAT will be kind of threadless, but when you want to actually use it, you have to kind of donate your thread. Oh, we get a...
How long this concurrent inter-object operations could be?
Very long. Like arbitrarily long.
If they are fast, you can have event loop per object.
Yeah. So there are some locks that have to be created and unlocked very quickly. But calling an object, so I'm thinking of this as a way to kind of structure the dependencies in your program actually. So, for example, when you start a server, like if you have like an object which represents like a long-running process, for example, a web server, something like that, right? It will actually kind of change its state and kind of become locked for a very long time, maybe even like days or weeks, as long as the object is kind of active. It will be calling different sub-objects.
Ah, so you want object mayhem. Busy. State when other objects shall wait until it idle to communicate.
Exactly, yes. And I want them to kind of still be kind of operational in this busy state, because busy state doesn't mean, you know, there is like a loop running, just burning the CPU. It means just something is happening. It means please wait. But I also want to reuse threads. So I have this, for example, here is an idea. So this function here, this is kind of how an external code could call AUTOMAT. So you are just calling get number of an object. So this is part of an object. We are within an object. And ignore this argument. It's not going to be necessary. We are just calling get number. And when this function is being called, I am spinning up a loop which will execute kind of tasks in AUTOMAT, which will kind of do the work, call any sub-objects which have to be called, kind of pass the continuation wherever it has to be passed, And after we are finished, we will kind of return back to the parent, whoever called us. Yeah, and return some value. So the external API is nice. So this way I can kind of steal the thread, and if somebody calls AUTOMAT, I can use the thread which calls AUTOMAT to run the processing loop and then return the result. Yeah. But, so there is the problem. Writing code in this style is super difficult. Because objects are kind of resumable. They have to be resumable. So this is a squarer. Squarer is an object that squares its target. It just looks a number, multiplies it by itself, and puts it in the result field. Yeah. But to properly do that, I have just so many extra machinery here. So when a squarer is being called, I don't know if I can return immediately. I have to basically check what object I am connected to. If this object that I am connected to is an integer, I can just multiply, put the value in the result, and kind of return. But if the target is something that has to be called to dynamically compute the value.
Kotlin has nice coroutines model.
Yeah. I actually don't know Kotlin coroutines, but
They use luxury of having its own compiler, so coroutines. Suspend. Functions internally have additional continuation argument, which holding coroutine context and state.
In C++, coroutines have just insane syntax. The syntax for coroutines is just... This is just total insanity. But once you implement them, once you follow this syntax, you have this kind of template for a coroutine. No, I'm not talking about coiled, because this is how you use coroutines. When you want to create a new type of coroutine, you have to do this crazy kind of template magic with the compiler classes. Like literally, like compiler will take your template and instantiate it with some of its own coroutine state blob that you have to manage yourself. So creating new types of coroutines is really messed up in C++. But once you create this template, they are also quite kind of nice to use.
Coiled XDD. Oh, I never even thought about that witchery. D.
I think there should be some samples here. Yeah, like task. This is like easy because somebody already wrote this coroutine. Increase the size. And again, generator, again, somebody wrote a generator, so it's easy, and the same lazy. Okay, this is how you create the new types of coroutines. You have to do that. And you have, yeah, so you have to define two classes. You have to define a coroutine class and a promise class. And then you can control what happens when, you know, for example, when a coroutine is being suspended. The fun thing about coroutines is that they are not actually related to multi-threading at all. They just allow you to have multiple stacks of execution, and you can jump between those two stacks.
Are they actually implemented by Klein 18 to usable extent?
Yep. So the base class for coroutines, this is essentially what you kind of need to work with them, and they are very well supported. There are some things which could be better, like there are those utility classes like task and generator or lazy, and if I remember correctly, they are not really widely available. But the compiler support is there. So if you just copy like a source file from GitHub with an implementation of a generator, you have a generator.
Wow, that is cool, actually. Last time I checked, it was red blob and support table XDIL.
Maybe it's not implemented in the STL, but the compiler itself should have this. It says partial. Okay, I didn't try it on Windows, so maybe Windows could have some issues, I don't know. But if I copy this code here, there was a small coroutine example.
I'm looking on CPF. Now it's more green than red, which is cool.
Yeah, so C++ coroutines are very, very nice. They give you very precise control over everything that happens. There is just one tiny thing which they don't give, and this is the... So when you create a coroutine, a compiler will dynamically allocate memory for it using the kind of allocator that... I don't think you can specify the allocator for the coroutine itself. This is the only limitation. But besides that, they are almost free. But a single dynamic allocation is not a big deal. Let me fix the macro because it's totally broke. Stop. Rewind. I don't think I will try to write any coroutines actually. I just mentioned this idea. I think I will first implement a couple objects using the terrible writing style, where I have to kind of manually handle like resumption of objects, and after I implement a couple of objects like that, maybe then I will think about coroutines. There is a duct tape coroutine approach also. I can just pass an integer into a function and I can resume the function using this integer. Essentially, yeah. I will call okay. So phased execution, probably not. Coroutines, probably not. And this I have some kind of example code which creates a network of objects that call each other and kind of wait for each other. So the basic structure is working. So I'm looking into this because if objects can be executed concurrently, it will help with the desync issues. Because when we have a desync issues, they are mostly caused by rendering. Rendering is just slow. It's always going to be slow, even if I optimize it. It can block for multiple milliseconds. And multiple milliseconds is... it's just totally unacceptable if we want to do stuff fast. So when there is this timer thread that wakes up and sends like a message into AUTOMAT, I think this timer thread should just directly execute the target objects. Like not even send messages to other threads. It will just, the timer thread will immediately execute, for example, the key press.
The evil Rutsero says,
Okay, now Twitch. Is this stream gaming or programming? X diet.
It has layers. It's like an onion. So if we can execute objects from the background without this single thread that blocks, we can bring latency very, very low. wanted to check something instead of conditional variable. I wonder, maybe instead of callback I will use next. How that will look like. Okay.
Oh, I see you still didn't update Skia to version where fonts upheat change.
Yeah, I'm trying to avoid it. I'm actually thinking about pinning. Yeah, I have your code, by the way, that fixes the font. It's somewhere in this document.
I have it too, stashed before each pull X die. Oh, wait. Timeline must stay in bird's radar radius in order to not spawn new one. It produces interesting result if you want to move it, and do not know that fact. XD.
I think this radius could be increased a little bit. It feels very... It feels that it's very small. Yeah. If you're on Windows, there could be issues with macro recording. On Linux things seem to work right now. On Windows I still have to fix them.
I'm on Wayland. I have even more issues. And for some reason, timeline can't be disabled with mouse click when it moved away from bird's radar radius.
Yeah. A recording, right?
Yes.
Still plenty of bugs to fix. They are small, but they are all over the place. Unfortunately, the bird is the only way to kind of operate with timeline. You can also delete it. When it's deleted, it also kind of stops.
Looking at 17 timelines interconnected with 6 key presser, all running at 9 FPS XD.
This is a good stress test. Actually, after we optimize the rendering, this should still work kind of decently. As long as things are static. Like, because if a connection doesn't move, we can really cache like even bitmap. We could render this to a tiny like, PNG file. Not PNG file, I mean like a transparent bitmap. Texture. Yeah. Render to texture.
AUTOMAT actually have very strange GPU usage.
URL.
Without OBS recording it, doing this much faster, but with same amplitude.
Have you been zooming or yeah, zooming maybe? Your usage is very weak. It renders itself using kind of busy loop. It just has a on Linux. It has a hot loop which doesn't really wait for screen refresh.
Sorry, it seems recording has sound. It was unintentional.
Oh yeah. I just noticed. I didn't even hear that. I think in terms of CPU and GPU usage, it should really go to sleep, like when it's not doing anything. When the window is just there, kind of hanging and not refreshing. We will do this. So in every object we'll put a boolean, and the boolean will store the value whether the object was updated. All of the objects that I see kind of on the
Well, it's not very big zooming, just to see 17 timelines.
I was asking about zooming because Skia does some caching, and at the different zoom levels, fonts, for instance, will have multiple. Skia will try to render fonts to a texture so that the text can be rendered faster. And those caches are probably being dropped every frame when zooming is happening. But the zooming has to be happening at the moment for this kind of effect to happen.
But same spiking happening with default zoom level, with few objects on table.
I have no clue what's that. The rendering loop of AUTOMAT is very stable. Like it redraws everything every frame. In AUTOMAT itself there is no caching, but there is caching in Skia, so something at a lower level could cause those oscillations. maybe some of the caches have like timeout, or maybe some of the caches could have bounded. You know, there is this cache approach where you have like a rolling buffer, and when you want to cache new information, you delete the old, and it goes like in a circle. That could also cause that.
Maybe almond-related bugs in Skia. Does Automat currently killing one enemy and retreating to save point?
Surprisingly, in this game, scaling works. Scaling is relatively flat, so even killing like the first enemies at the start of the game gives you like a decent amount of XP. So yeah, and it's been doing that for I think more than 24 hours in total now. It helped me beat the first boss.
Crazy.
Okay, in terms of prototyping, I think we're in a very good place. This looks like it could actually work. So the nice thing is that we don't really have any objects that are doing this call flow. At least not right now. Kind of combined the run, like the callback and the next pointers. Can we combine this more? Can we combine a call and run? Yeah, okay, I guess this is enough for today. We kind of prototype this new threading model. I think it could be improved. First of all, there are some similarities between run and call. I think we could merge those two. That's one. And second is that for executing logic, maybe we could use coroutines. I know, I will think about this. But okay, but on the next stream we are not going to work on this part. On the next stream we are going to fix some bugs so that it can be used on Windows. Yeah, we will continue doing stuff from the roadmap. So that's it for today. Thanks and see you on Friday. Bye.